first lab, how did the first lab look so far?
Real good, real good.
Oh, okay.
Okay, so let's go ahead now and let's talk about lab 2. Now, lab 2 actually, in my opinion, is easier than lab 1. But anyway, okay, so we go over to here. Okay, so let's see here. Okay, so this is the new write-up I did, and basically the lab is looking at so lab 2 is basically on density. And you're going to be doing two things here. You're going to be calculating various densities, and you're also going to be looking at also the typical way it's done using volume by displacement, and also using an analytical balance. Okay. So basically, we are going to, you're going to have 6 samples. You need 6 of these. One per sample, not one, but one per metal. Okay, and we're going to do it 3 times and then average the results. Okay, so that means you need to have a mass and a volume for each sample of the same thing. Okay, in this case, it's going to be purple. Okay, and purple is some substance. It could be plastic, it could be metal, it could be whatever. Okay, so to find the density of purple, we need a mass and we need a volume. Now, each time we're going to start with, we're doing volume, we're going to always start with 20 milliliters. And then we're going to dump in our metal or whatever. And then the volume is going to go up. The amount the volume goes up is the volume of the object we threw in the water. So if the object goes up to 40 and we start at 20, that means the object's volume is 20. If it went up to 30 and we started at 20, the volume's object is 10. Okay, so because of that, we always need to have an initial volume of the water we start with, and then the final volume after it goes up after we throw the object in it. Hence, we subtract the initial volume from the final volume. And that's what's going to go here. We also need to weigh the dry object. I'm going to repeat, this object being weighed here is dry. And if we were in lab, sometimes when you get your samples, they're wet because the class before you didn't dry them when they returned it. So you always make sure they're very dry before we weigh it because water has mass. Okay, so sample 1, 2, 3. So you're going to have a mass for sample 1, a volume for sample 1. And then you're going to be putting, that's from here, over volume. And then this is going to be that calculation after you've done the average. And the metal sample is purple. And then to do the accepted value, you go to the very, oh, I didn't include that. At the very end of the PowerPoint, there are all the official values. And then you're going to calculate the error. So to calculate error, it's you're going to subtract your value from the accepted value at the end of the PowerPoint over the accepted value. And this needs to be absolute value. In other words, no negative, times 100. And that'll give you percent error. Okay, so you're gonna have 6 different samples. So you need 6 of these tables here. Each time you're gonna be sampling different versions of the same metal. And you're gonna get 3 different readings depending on, because you're gonna get different sizes and different masses. Then you're gonna average those densities together. In other words, you're gonna take this plus that, all divided by 3. And that'll give you your average density of the 3 samples. You're going to then compare that to the value at the end of the last slide. And that'll be the accepted value. You're going to subtract yours from that over the accepted times 100, and that'll give you a percent error. Okay, let me show you the PowerPoint here. I'll come back to this. Let's see here. This is the PowerPoint. You go to the very, very end. And these are the values here. So these are the official values here. So here's the purple right here. Oops. Excuse me. So you can be comparing the 1.37 It's going to be 1.37. So your value may be, average is like 132, 1.32. Let's say yours was 132. So you'd say 137 minus 132, all over 137 times 100. Okay, so what would that be? It would be 3.65%. But your value is going to be something other than 3.32. I just came up with that value as an example. Okay. So do not put down 3.65 because your value is going to be different based on your calculations. Okay, does that make sense? You're going to be doing 6 of these. And then be doing, an average, you're going to be doing, and then a percent error for all 6. Then you'll be answering the questions, like always. And you're going to be doing a conclusion, like always. All right, does that make more sense? You guys. Does that make more sense?
Oh, yeah, sorry, it's all clear for me. Thank you.
Okay. Okay, all right. So I'm going to do a video per lab. As these go along, I'm seeing that I inherited these labs, so I'm trying to make them clearer. I think one, the PowerPoint, the back slide was reversed. She just couldn't read it. It was back. I had to flip that around. Anyway. Okay. All right. So hopefully that helped.